All right, so we're going to be looking at the practice test for Chapter 1. And remember, the great thing about having a video is you have total control, so you can pause at any time, go back and look at problems again, pause, work through a problem, then hear the answer. You're in charge. All right, so on the first question, they're asking us to figure out whether or not these are proportional by graphing. So proportional by graphing. And remember, to be proportional, when we graph, we need to see two things. We need to see a straight line and that line needs to go through the origin. So those are the two things that have to happen for it to be proportional. It has to create a straight line, and that straight line has to go through the origin. So with this problem, they give us a table, 3 different sets of points. This first set of points is 1, 1. Side length of 1 foot, volume of 1 cubic foot. So 1 and 1. So go out 1, go up 1. 1's going to be right there between 0 and 3. Next, 2 and 8. So it helps sometimes if you put the points down and then know that you're going to end up graphing those points. So 2 and 8. 8's going to be 2/3 between 6 and 9. And finally, our last point, 3 and 27. 3 and 27. Now we're going to put a line through the points. So does it go through the origin? Well, it comes down. It might. In fact, that would make sense. It would make sense that if there was no length, there would be no volume. But what we're going to find on this one is it fails the straight line test, because when we grab a line and we start to connect points, we see that those points don't go through the line. Or excuse me, that the line doesn't go through the points. My line's off just slightly. Let me see if I can get my line so it's a little better line. There we go. Push it down onto those points. So you'll notice that line that goes on forever, here were my 2 points were. My first point was at 1, 1. So I had a point at 1, 1 right about there, and I had a point at 2, 8 right about there. You'll notice those first 2 points are great, but it's never going to go through that third point. So this is not proportional. Let's look at the second graphing question. Now, again, if you need to go back and review any of that, you're in total control. For the second one, again, we have 3 points. We have the point 3, 15. Let me change that to something a little bit darker. We have the point 3, 15. So 3 and 15 is going to be right there. We have the point 420. So when you use 4 hours of driving, when you have 4 hours of driving, you'll use 20 gallons of gas. So 20 is going to be right about there between 18 and 21. And then finally, we're going to have the point 525, 524, 25. And now we're starting to look at something that looks like it's going to create a straight line. And it looks like that straight line will probably go through the origin. So let's find out. So let's get our line tool out. You should do this with a ruler. On the test, you can have rulers. And we're going to see, does this create a straight line that goes through the origin? And yes, it does. Straight line through the origin. This is proportional. This is, I have to get rid of the straight line tool so I can make an S. This is proportional. It passes both things. Yes, it goes through the origin. Yes, it makes a straight line through all the points. Alrighty, on to the next section. So here we're asked whether each pair of ratios forms a proportion. And there are 2 methods that we can use, 2 primary methods that we use. One is the method of simplifying to see if everything simplifies to the same ratio. And the second is the method of using cross products to see if everything has the same product. And I'm going to do both of those on this first problem so you can see them both work. So let's do the simplifying first. Over here I'm going to take my two ratios, 6 to 8, 15 to 20, and I'm going to simplify them. 6 to 8 simplifies to 3 over 4. 2 goes into 6 3 times, 2 goes into 8 4 times. 15 over 20 also simplifies to 3 over 4. 15 divided by 5 is 3, 20 divided by 5 is 4. This is proportional because these are the same. Since these are the same amount, this is a proportion. Now that we know it is, let's look at the second way that we can determine that. And here's way number 2. Way number 2, and let me zoom in for a moment here. So let's zoom in on this problem. Here's way number 2. Way number 2 is to go ahead and to take each of these and do the cross. So what we're going to do is we're going to multiply the 8 and the 15. So we're going to multiply 15 times 8. So 8 times 15 equals 120. This has a product of 120. Then we're going to do the same thing with the 6 and the 20. So we're going to multiply 6 by 20. So 6 times 20, and that also equals 120. And since those are the same, we know this is truly a proportion. So those are your two ways to check, and the way that you use will depend on the kind of problem you're given. Okay, so in this method, on the second problem, I'm going to look at these, and these really don't simplify well. So instead, I'm going to use the idea of cross products. I'm going to multiply the 9 times the 11. So 9 times 11 gives me 99. And I'm going to multiply 16 times 6. 16 times 6 gives me 96. And since these are not the same, since I know that 99 does not equal 96, I know that this one is not a proportion. They have to be the same, just like these were the same, 120 and 120. All right? On this last one, on number 3, yes, and the numbering's all off because these were just cut and paste to give you some good example problems. On number 3, these look like problems that could be simplified. 6 over 8 simplifies to 3 over 4 pretty quickly. And 9 over 12 simplifies to 3 over 4. 3 goes into 9 3 times, 3 goes into 12 4 times. Since those simplify to the same ratio, this is a proportion. So it doesn't matter which method you use, whether you use the cross products or you use the simplifying, either one will let you figure out whether something is or is not a proportion. The cross products is what we were using to solve proportions. So let's go down to the problem labeled number 16. And we're going to solve this. And this is where I gave you that example of putting the dashed line down. And you're going to multiply across. So you're going to have 10 times 8. And that's going to equal 5 times W. So 10 times 8 is 80 equals 5 times W is 5W. Then we identify that 5 here is the coefficient. 5 tells us how many W's there are. What we want to find out is how much 1W equals. That's our goal. So to figure out what 1W equals, if we have 5 W's, we need to divide that by 5. And if we do it on that side, we also do it on this side. We divide it by 5 because this gives us 1. 1 times W is W. And 80 divided by 5 is 16. Now I can use what I learned in the last set of problems to check my work on this. And here's how I would check my work. I'd say 10 times 8 is 80. If my answer is correct, if this is 16, then 5 times 16 should also be 80. I'll just use my calculator to prove it. 5 times 16, look at that, also 80. I know that that answer works. I know that I like that answer. Give it a check mark, make that a smiley face. 16 is a good answer, good solution to that problem. Now, if you were stuck on these earlier and you want to rework 17 now, pause the video and work it before I discuss the answer. All right, 17. So on problem 17, we're going to do the same idea. We're going to multiply x times 15. That's this, x times 15. And we're going to multiply 9 times 4. Those amounts need to equal each other, so I'm going to go ahead and put that line down. That line reminds me that to be equal, I have to keep doing the same thing on both sides. When I do x times 15, I get 15x. 9 times 4, I get 36. The coefficient of x is 15, so I have to divide both sides by 15. When I divide by 15, I get a 1 right here. And 1 times x is x. That's what I'm solving for. Now, I know in the past some students have gotten to this point and they've said, I must have done something wrong because 15 can't go into 36. Well, it can go in. It just doesn't go in evenly. But that's okay. You're going to do more and more things here where you're not having things go in evenly. So 36 can be divided by 15. If we get out our calculator and do 36 divided by 15, it goes in 2.4 times. So sometimes our answers are not going to be whole numbers. This is going to be 2.4 times. If I want to check my work, I can check my work by saying, all right, 9 times the 4, cross products, that's 36. I'm saying my answer, I'm saying x is equal to 2.4. So is 2.4, let me work on my writing 4s there, that wasn't a very good 4, is 2.4 times 15 also 36? Let's see, 2.4 times 15 equals 36, and that tells me that I did it correctly. I can feel good about that answer right there. Last one in this group. So I'm going to show you a different way to solve here. And again, the type of problem you're given will determine the type of solution you use. If you look at 7 and 84, does 7 go in evenly to 84? That's worth checking. Does 7 go into 84 evenly? If you take 84 and you divide it by 7, do you get a whole number? You do. You get 12. That's 12 times 7 to get 84. So then the question is, what would you multiply by z, or what would z have to be if you're going to multiply it by 12 and you're going to get 12 as an answer? Well, if you're going to multiply something by 12 and get 12 as an answer, the thing you started with had to be 1. 1 times 12 is 12. So here the correct answer is that z equals 1. And to prove it, we're going to go back to that same idea. We're going to do 7 times 12. That's 84. 7 times 12, we'll confirm it. That's 84. And 1 times 84 is also 84. We can feel pretty confident with that answer. It's worth taking the time to check. It only takes, that took me less than 30 seconds to check it. It's worth taking the time to check. Okay, to the back page, Get rid of our calculator. So, During Tracy's trip across country, she traveled 2,884 miles. It took 7 days. Find a unit rate. I would suggest you highlight that. Find a unit rate to represent the miles she traveled per day. Miles per day. So we know that our answer is going to be in miles per day. If I turn that into a ratio, it looks like this. Miles per day. That helps me then pull information from the problem. Miles, 2,884. Days, 7. I know that if it's going to be a unit rate, that has to be a 1. What do I do to get that to 1? I divide by 7. So here I'm going to divide by 7. And when I divide 284, and I divide it by 7, I get 412. 412 is the number of miles, so 412 miles per day. And I could check. I can multiply to 7 times 412. Let's take the 412. Let's multiply by 7. Yep, that's the 2,084. That would be those two multiplied together. All right, let's show the calculator over there, and let's look at the next problem. 12-ounce bottle of shampoo lasts Enrique 16 weeks. How long will an 18-ounce bottle of the same brand last? So we want to know how long the ounces in the week. So we're going to do ounces and weeks. We know that 12 ounces lasts 16 weeks. What we want to know is how many ounces to get through, or excuse me, I started to write it incorrectly. Let me go back. We want to know 18 ounces will be how many weeks? Because the question is how long? How long would you expect an 18-ounce bottle to last? And the long is in weeks. So we can go ahead and we could start multiplying across. I'm going to just suggest to you that one thing you could do to make this a little easier, it would be to simplify. So 12 and 16 simplifies down to 3 over 4. Now you don't have to do this. I'm just letting you know that my experience is it's easier if you simplify the problem. So we have now 3 in 4 weeks, 3 ounces, 4 weeks, 18 ounces, how many weeks? And we're going to do that multiplying across. We're going to multiply these two together, 4 times 18, and multiply these two together, 3 times x. So 4 times 18, 72 equals 3x. Notice I didn't draw my line down. Let me just draw that. You don't need this dashed line. It just helps you remember to do the same thing on both sides. I don't want to know what 3x's are. I want to know what x is. So since I'm trying to find x, I know that I need to divide this 3x by that coefficient x. I need to divide by the coefficient, so I get a 1 right there. 1 times x is x. I need to divide the 72 by the 3 also. Whatever I do on one side, have to do on the other. And I get 24. How long would you expect it to last? You would expect it to last 24 weeks. Let's keep going down. Let's do the swimming pool problem next. Actually, let's jump over and do this one. This is a good one to do before the swimming pool. So the bookshelves. Bookshelves hold 43 books on each shelf. I would highlight that. 43 books on each shelf. That tells me that this is going to be proportional, because on the first shelf there will be 43 books. And if you have 2 shelves, it will be 2 times 43 books, or 86 books. And if you have 3 shelves, it will be 3 shelves at 43 books each. And that looks like 129. Let me just double check that on my calculator. Looks like 129. Yep, 129. These all simplify to the same thing. 43 books on one shelf is the same rate as 86 on 2, is the same rate as 129 on 3. So yes, this is proportional. Yes, proportional. Now let's look at the recreation problem. And again, if I'm going too fast for you, you can always slow it down. That's the great thing about you controlling the video. So let's look at the recreation problem. An outdoor pool costs $8 per day, so there's an important piece of information, $8 per day. And there's also, so let's just pick up a different color here. There's also a $25 yearly registration fee. So if I go use the pool for one day, I have to pay $25, that's the registration, plus I pay $8, that's the daily fee. If I went and used the pool one time during the summer, I would pay a total of $33. That's what it would cost me if I signed up for the pool and only went one time. Now, if I went more than one time, let's say I went 2 times, well, the first time I arrive, I've got the registration that I have to pay. Each day I swim, I'm going to pay $8. So I'm going to pay 2 days now at $8. So I'm going to pay 25 plus 16. I'm going to pay $41 to go twice. 41. Now the question they're asking me is this proportional? Is the cost proportional? I want to change colors there. I thought I changed highlighters. Is the cost proportional? And the answer is no, it's not, because of that fee. As soon as you put that fee in, it stops being proportional, because it's now $33 for one day, but $41 for 2. Pardon me. If it was going to be proportional, it'd be $33 for one day, $66 for 2 days, $99 for 3 days. But it's not, because you have that fee. It is not a proportional relationship. So no, not proportional. Last 2 problems, and I don't think we'll need our calculator on this one. Well, we might in a minute, but we'll put it away temporarily. Write the ratios in the table to show what's going on. So here's the first ratio, $11 for 1 package. Here's the next ratio, $20 for 2 packages. That simplifies to $10 for 1 package. We can already see this is not proportional. The next one, $29 for 3 packages. I am going to want that calculator. Might as well use real tools here for these problems. So I'm going to use the calculator, and that tells me that if I have 3 packages for 29, 29 divided by 3 is $9.67 for a package. The unit rate would be $9.67. And finally, for 4 packages, I'm going to pay $38 for 4 packages. I'm going to just put my dollar signs on. It just cleans up my work if I keep that idea of keeping my dollars. What's it going to be for 1? Well, it's going to be 38 divided by 4, and that's going to be $9.50. So each time you add more packages, it gets a little bit cheaper. They give you a break because they're making more overall money, $38 for 4, so they don't need to make as much for each package. Lastly, here we go. Is this proportional or not proportional? Well, this is proportional. Number of hours worked, amount earned. You earn 99 cents. This is if you lived in 1925 or something. You earn 99 cents for 1 hour. You earn $1.98 for 2 hours, which is the same as 99 cents for 1 hour. If we do 198 and we divide it by 2, we find out it's 99 cents again. And for 3 hours, you earn $2.97. For 3 hours, that also works out to 99 cents for 1 hour. 297 divided by 3. And this one also works out. $3.96 for 4 hours worth of work works out to be 99 cents an hour. So there you go. You can review this, use this to help you study for Monday's test. Plan on coming in and being really successful. If you have more questions, be sure you ask.